Hey guys, welcome back to the channel. In a previous lecture, we have discussed one of the feature extraction technique bag of word in NLP. Now in today's lecture, we are going to learn about another feature extraction techniques which is TF-IDF in NLP. So let's get started. So before start TF-IDF, we revise what is the problem with the bag of word. So here some of the disadvantages of bag of word. Ordered or structure of words in paragraph is ignored by the bag of word. Another disadvantage is it is only concerned with occurrence of words, not its position in paragraph. And the last one is it disregards the grammatical details and treats every word equally. So here some of the disadvantages of bag of words are overcome by the TF-IDF. Here in bag of word, every word treated as a equally, whereas in TF-IDF we can come to know which words are more important as compared to another words in particular paragraph. So before going to start TF-IDF, here are the two terminology that we need to understand first. The first is the word term. Here term means one word. For example, my name is here. So here in particular sentence there are three words. So which means there are three terms available in the sentence. Likewise, whenever we use document word in TF-IDF which refers paragraph or a corpus or any text file, PDF file or number of sentences. Please keep it remember while we are learn TF-IDF. So first of all, TF-IDF stands for Terms Frequency Inverse Document Frequency. The purpose of TF-IDF is to calculate the importance of a word within a corpus or set of documents. So basically we come to know which words are most important as compared to other words in particular corpus, or we can say paragraph, right? Here's the formula of TF-IDF. WXY is equal to TF-XY multiply log and divide by DF of X, where term word X within document paragraphs, or we can say paragraph of Y, right? So here we can say TF-XY, which implies frequency of X in Y. DF of X is equal to number of documents containing X, and N means total number of documents, right? Let's separate this formula and understand each of these component one by one, right? So here, as the name implies, TF-IDF is composed of two subparts which are terms frequency, which is TF, and inverse document frequency, IDF, right? So let's understand one by one. So first, TF, which means term frequency, specifies how frequently a term appear in entire document. So basically it tells which words comes how many times in particular document, or we can say paragraph. It can be thought of as a probability of finding a word within a document. It calculates number of times a word occurs in a review, or we can say paragraph, with respect to total number of words in the review, right? So as we have seen in our formula, this TF of XY refers to terms frequency. Second subpart is inverse document frequency. The inverse document frequency is a measure of whether a term is rare or frequent across the documents in the entire corpus, right? It also highlights those words which occurs in very few documents across the corpus, right? So basically IDF suggests the most frequent word or most rare words in particular data set, or we can say documents, right? So in our formula, the log component refer to IDF, right? Now let's understand TF-IDF calculation step by step in detail, right? So here we have three reviews. Review 1, this product is not costly but it is very nice. The review 2, this product is nice but costly. Review 3, this product is good. So first of all, what we can do, first we make vocabulary. So here the words are in these three sentences, right? So let's calculate terms frequency for review 1, right? So step 1, count number of words in review 1. So our review 1 is, this product is not costly but it is very nice. So here we have 10 words, or we can say 10 terms in review 1. Second, calculate term frequency of each word in the review 1. So here the first word is this. So how we will calculate? First of all, we find number of times this word appear in review 1. So here we have, so here one time only this word is come entire sentence, and number of words of or terms in review 1. So here we have 10 words, so 1 by 10. So term frequency of this word in review 1 is 1 by 10, right? Likewise, we can calculate every word of term frequency. Here we can see every word is appear only one time in entire review 1 sentence except is word. So is word appear in 2 times. Here we can see is and is. So is word is appear 2 times in entire sentence. So the calculation is 2 divided by 10, which is 1 by 5 for this word. So this way we can find term frequency, right? In the first column we put every word in our vocabulary, then we find the second column, then we calculate term frequency for review 1 in our second column. Here good word is not available in review 1, so we put directly 0. Likewise, we can calculate term frequency of review 2 and term frequency of review 3, right? Now we can calculate inverse document frequency IDF. So here we have same 3 sentences. First of all, we make a vocabulary, and now we calculate IDF for entire vocabulary. So first of all, we count number of records or documents in our data set. So here we have 3 reviews, so number of documents are 3. Second, calculate inverse document frequency of each word in our vocab. The first word of vocab is this. So how we will find IDF? So first of all, we find number of documents. So number of document is 3. Then we need to find number of documents containing the word this. So here we can see all of these words, these sentences have this word. So here we put 3. So the formula is log 3 divided by 3 is equal to log 1, and the value of log 1 is 0, right? Likewise, we can calculate IDF for all these vocabularies words. Here we can see the IDF for product word is 0, is word is 0. Here we can see the word not has 0.48 IDF value. Likewise, we can see here nice word has 0.18, good word has 0.48, right? So it is, the calculation is pretty easy, right? So to conclude, we can say the words like is, this, etc. are less important as the IDF value is almost 0, and the words very, costly, good are more important as you can see the value of these words, right? So that's how we can calculate most important words and most rare word in particular purpose using IDF formula, right? Now to find term frequency and inverse document frequency, which means TF-IDF, we need to multiply TF value and IDF value. So here you can see we multiply the TF value of this multiplied by IDF value of this, which is 1 divided by 10 multiplied by 0, which means 0. So TF-IDF for this word is 0. Likewise, we can find TF-IDF value for each word. So here you can see 0, 0, 4.8 for not word, 1.8 for costly word. Now here you can see the numeric representation of these three reviews: review 1, review 2 and review 3. For the review 1, you can see the numeric vector 0, 0, 0, 4.8, 1.8, 1.8, 4.8, 4.8, 1.8 and 0. Likewise, you can here see review 2 and review 3. So this numerical representation goes into the our NLP model, and you can also perform various tasks according to your requirement. Like if you want to perform sentiment analysis, then you can use this numeric representation vector and you can perform this sentiment analysis task. So that's it for the TF-IDF theory. Now we can directly jump to the Jupyter Notebook to see implementation of TF-IDF. Here I import pandas library and TF-IDF vector in sklearn feature extraction .text. Right here I have put 4 sentences as a list in corpus variable. Now first of all, we need to make an object of TF-IDF vector and store it into TF-IDF model variable. Now you can see here by using feed underscore transform function, we can find value of TF-IDF of each these words, right? So you can see TF-IDF model dot feed underscore transform and put corpus into the parameter. So here you can see 0 refers first sentence, this 1, 3, 6 refers the position of the words in particular first sentence into the vocabulary. So which means data is come on the first index in vocabulary, right? And the value of data is 0.2574. Likewise, you can see all the TF-IDF value of each words in each sentence, right? To see the proper format, you just need to put dot to tens at last, so you can see the proper formatted vector of each sentence. Here you can see the first sentence, this is the second sentence, right? Here you can see the vocabulary by using vocabulary underscore attribute, right? And you can also make a data frame by using pd.dataframe. You just need to put entire feed transform syntax, and for the column you just need to use vocabulary. So here I am sorting the vocabulary, so you just need to write sorted in bracket TF-IDF model dot vocabulary underscore. right? And here you can see 4 rows and 26 columns, which means vocabulary size is 26. Unique words of our data set is 26, right? Now by using max underscore features, you can find most frequent words into the data set. So here I have wrote 10, which means these 10 words are most frequently come in our 4 sentences. This is it for the TF-IDF. In the next lecture, we are going to see simple sentiment analysis, in which we are going to use TF-IDF as a feature extraction techniques, and to make every sentence or every review in a numerical format by using TF-IDF, and we can use one of the classification algorithm and do the task.